With the increasing popularity of mobile internet and the higher bandwidth requirement of mobile applications, user quality of experience is particularly important. For applications requiring high bandwidth and low delay, such as video streaming, video conferencing, and online gaming, bandwidth specifically refers to the capacity at which a network can transmit data. For example, if the bandwidth of a network is 5 megabits per second, it implies that the network cannot transmit data faster than this. If the future bandwidth can be estimated in advance, applications can leverage the estimation to adjust their data transmission strategies and significantly improve the user QoE. In our research, we focus on accurate bandwidth prediction to improve user experience.
The first part of our research is bandwidth data collection. This requires us to have a server which sends data out and a client that receives data. We use a software called iPerf to facilitate this process. We use our computer as a server. We activate the iPerf as a server in terminal. Then using the client mode on our phone, we can have a bandwidth conversation between them. As we can see, when they are synced, specific bandwidth data per second appear on both screens. After that, we left our server inside and went out for different routes, such as across campus and our apartment. We also try a cooler style such as skateboarding while recording data. That's not important. Most importantly, we went for daily commute transportation such as the 7 train to see the real-world scenarios. The next step is to make different prediction models. We first use the traditional model LSTM. We also apply the transformer and time FM models. We use LSTM as baseline for evaluating the other two. LSTM is a traditional deep learning network used for time series prediction. It contains a bunch of hidden layers and memory cells that allows it to compare the current inputs from past information. It's basically machine learning with accentuation on memory. Li Fan, a PhD at NYU specializing in communication networks, found that by using LSTM, the next second prediction error ratio can be lowered to 23.3%. Pretty good for bandwidth already. The next model we implement is the transformer model. Used to train ChatGPT, transformer focuses on self-attention, a mechanism that calculates how interrelated each data point is compared to others. Using Python's built-in transformer models and adjusting it to accommodate our purpose, we successfully use transformer for prediction. However, as it shows, even though the prediction curves fit the ground truth very well, the error ratio is still 2% worse than that of the LSTM. Therefore, we might need a more powerful model for the versatile bandwidth.
The last machine learning model we tried is the time series foundation model, a newly released decoder-only model developed by Google. Let's take a close look of the interior structure of the time series foundation model. The model takes a certain amount of time points to be a batch. For example, the batch size here is 32, which means we treat 32 time points as a batch. Each batch is then tokenized and passed into the transformer layer with its positional encoding. Then it can make the prediction of the future 4 batches. Here are 2 parameters we want to change. The first one is contact length, and the second one is horizon length. The contact length means the length we want to look back, and based on this, we make the prediction. And for the horizon length, it doesn't need to be the batch size. So we make it to be 1, which means we only want to predict the future 1 second of the bandwidth. We tried rolling prediction, and we used this amount of seconds in our data sample. And we did 4 experiments in total. All the experiments have different contact length, but they have the same horizon length to be 1. Here are the results. As we can see, the longer the contact length, the better the performance of the model on bandwidth prediction. For our future work, we want to incorporate the advantages of different models to create a hybrid model to beat the prediction accuracy barrier. Also, we aim to collect larger and more diverse data, either by our own or by an ongoing negotiation between a company called Speed Test. For sure, we will keep on our endeavor to improve the bandwidth prediction technique that enables us to enjoy the streaming world with faster speed and better quality.